35 grams of lead-2 nitrate dissolved in water is reacted with 7 grams of ammonium hydroxide, also dissolved in water. Calculate the mass of lead-2 hydroxide formed. This is a so-called precipitation reaction. It used to be called a double decomposition reaction. What happens here is they essentially swap partners. The lead takes the hydroxide, the ammonium takes the nitrate. That's what you see on the right. The two chemicals on the left, as described in the question, are dissolved in water, as indicated by the subscript aqueous. The lead hydroxide is insoluble, indicated by the subscript S for solid, and the down arrow, which is known as a precipitation arrow. You need a 2 in front of the NH4OH to balance the hydroxides and the PbOH twice on the right. And once you have two NH4s on the left, you need to put a 2 in front of the NH4NO3 to balance the equation. When you mix the two chemicals on the left, this is what happens instantly. A white precipitate of lead hydroxide forms. The other chemical, ammonium nitrate, is soluble and remains in solution. We need to use the numbers in the balanced equation to solve this question. Where there isn't a number in front of the formula, it's taken to be 1. So 1 mole of PbNO3 twice reacts with 2 moles of NH4OH to produce 1 mole of PbOH twice. This is the product we have to consider, as well as 2 moles of ammonium nitrate. Now this is a so-called limiting reactant or limiting reagent question, which is slightly more difficult than the questions you might have tried elsewhere. You see in the question we're reacting 1 mole of lead nitrate with 2 moles of ammonium hydroxide. Now here's an analogy. Look at the picture and see how many bicycles you can form from these bits and pieces. How many bicycles? Do we have the right number of wheels and frames? So we take a frame, we'd have to add 2 wheels. This is a bit like the balanced equation we're dealing with, as you'll see when we return to it. Again, we can take another frame and 2 wheels. So we've completed 2 bicycles at this stage from the bits and pieces. Third frame. So now we have got 3 completed bicycles. Now we still have some frames and a wheel. But we can't make a 4th bicycle. At least we can't make a complete bicycle. What have we run out of first? Well, we've run out of wheels. So while we start with 5 frames and 7 wheels, actually we only used 3 frames and 6 wheels to produce 3 bicycles. It was the wheels that ran out first, so the wheels represent the limiting factor. They dictate the number of bicycles. There were 7 wheels, we were only able to make 3 bicycles. So returning to the balanced equation, 1 mole of nitrate reacting with 2 moles of ammonium hydroxide. Rather like 1 frame, 2 wheels. A little bit harder though, because we've got to change from mole to mass and backwards. So we need to work out the formula mass of PbNO3 twice, 1 Pb. There's a 2 outside the brackets, so we need 2 of everything inside the brackets. So it's 2 N's and 2 3's are 6 oxygens. Gives a grand total of 331. That's the formula mass of PbNO3 twice. M subscript R stands for the relative molecular mass, so 331. We do the same now for the NH4OH. And this is a common mistake here, not knowing when to use and not use the 2 in the balanced equation. All I'm doing here is working out the formula mass of NH4OH. We're not using that 2 in the balanced equation here, not at this stage. So the formula mass of NH4OH comes out to be 35. That's all I want. I just want the formula mass at this stage. The reason I need the formula mass is to change the mass that we've been given in the question into moles. So look at the question. We've got 35 grams of lead-2 nitrate. We work with moles in chemistry and we must get the mass into moles to make it meaningful. So we divide the mass 35 by the formula mass 331, and that will give us the number of moles of lead-2 nitrate that we have in the question, namely 0.106. Again, we're not using this 2 in the balanced equation just yet. We're just changing from mass to moles. So in regard to ammonium hydroxide, 7 grams. In the question, we divide by the formula mass 35 to change it to moles, and that comes out to be 0.2 moles. You might like to pause here and figure out for yourself which chemical is going to run out. And it's the ammonium hydroxide is going to run out. They react in the ratio 1 to 2. And you'll notice the 0.106 is a slight excess. Actually, what will react here will be 0.1 moles of lead nitrate with 0.2 moles of ammonium hydroxide. So in this case, the ammonium hydroxide is the limiting factor. We say the lead nitrate is an excess. What will control, therefore, the mass of lead hydroxide formed will be the limiting factor, namely the ammonium hydroxide. So like in any other reacting mass question, we make a relationship between two chemicals. We see, using the numbers in the balance equation, that 2 moles of ammonium hydroxide gives 1 mole of lead hydroxide. What we do now is we change to mass. You recall that we worked out, we changed to mass. You recall that we worked out the formula mass of ammonium hydroxide to be 35 earlier. And this is where we use the 2. There's 2 moles of ammonium hydroxide, so we multiply the 35 by 2 and get 70. So 2 moles of ammonium hydroxide weighs 70 grams. That's where we use the 2 in the balanced equation. And it's a common problem for students not knowing when to use it and not to use it. That was the one and only place we used the number in the balance equation. We do the same working out the formula mass of PbOH twice. 1 lead, 2 oxygens, 2 hydrogens. Grand total of 241. You'll notice that we have 1 mole of PbOH twice, so there's no multiplying here. It's just simply 241 grams. So there's our relationship, our reacting mass. 70 grams of NH4OH gives 241 grams of PbOH twice. Typically what you should do now is work out what 1 gram of ammonium hydroxide would produce. So to get 1 gram, you divide 70 by itself to get 1. You've divided the left side by 70, do the same to the right side. Once you've worked out what 1 gram of NH4OH would produce by way of PbOH twice, it's easy to work out what any other number of grams would produce. You might like to pause here. So to get what 7 grams of ammonium hydroxide would produce, you multiply both sides by 7. And there's the computation, comes out as 24.1 grams of lead hydroxide, PbOH twice, from 7 grams of ammonium hydroxide and slight excess of the other chemical.